In the last video, we checked whether or not superhosts and non-superhosts offered different prices. And we found that the price difference between superhosts and non-superhosts were statistically significantly different from zero. So, but is this difference just due to the fact that we have two groups, or might there be some confounding variable at play here? So, without an experiment, the best way to find differences would be an experiment or a randomized A/B test. Without that, we have to be very careful about confounding variables, because what if the number of bedrooms is a confounding variable? For example, you have the price, and we just looked at superhost status, and whether or not people were superhosts, and we found that it had an effect on the price offered. But what if something else has an impact on the price? For example, the number of bedrooms. Okay, so for example, the number of bedrooms, it should affect the price. More bedrooms, the more price you can get for your apartment, and this would not be a confounding variable if the number of bedrooms were equal among superhosts and non-superhosts. Okay, so if you could kind of if you have a difference here, or if you have a correlation, then, and you have a correlation between bedrooms and price, then the number of bedrooms would be a confounding variable. Okay, so and one way to control for this is to hold the number of bedrooms constant. For example, we could look at a subset of data. We could slice the data and only look at matching levels of the confounding variable. So for example, we could compare superhost and non-superhost listings with only 2 bedrooms. Okay, and we do that by using the t-test as in the previous video, but we just include this if bedrooms are strictly equal to 2. Okay, and we get the t-test result, and we have the difference between the means. This is the difference between the sample mean of non-super hosts and the sample mean of superhosts, and we found that this time it's negative, and with a standard error of 34, which means that the p-value for a difference of a positive difference is actually 0.82, which is very high. And why is that? Well, by restricting the sample to listings with only 2 bedrooms, we have eliminated bedroom as a confounding variable, but it reduces our sample size. Okay, so for example, here we only have 243 superhosts in our data set if we only count those superhosts which have 2 available bedrooms in their apartment, whereas if we go up here, we had 1114 in the whole data set. And in the whole data set, we had 7,292 non-superhost entries, whereas if we only look at the data slice with only 2 bedrooms, then we are left with only 1,836 samples. Okay, which means that the standard errors here, and here of the means and the difference, they are a lot higher. So for example, the standard error of the difference is now 34, whereas it was only 15 when we used the whole data set. Okay, which means that we failed to reject our null hypothesis, but we get a weak signal. Okay, we only use some part of our data, and importantly, if we look at listings with only 1 or maybe 3 bedrooms, then what are the differences? We can't use this method to say something about the whole population. So that's why we are going to use regression analysis to overcome these issues. Okay, so for example, we can estimate separate simple regression models for each of the superhosts and the non-superhosts. For example, we have for the superhosts or the non-superhosts, we have some data, and this can be the superhosts, and then we just make a line here. We draw the regression line, and this is the y hat for non-superhost, and maybe we have this for superhost. Okay, and we have some data for the superhosts, and we get this this regression line. Okay, so this is y hat for the superhosts. Okay, so you see that now we can use these regression lines to say something about the price offered by these 2 groups, adjusted for the number of bedrooms. Okay, so we can say something about the price given the number of bedrooms. Okay, so now we have used all our data to compare prices, and for example, if we look at 3 bedrooms, then we have a certain difference given 3 bedrooms. Okay, so now, given 3 bedrooms, we see that super users actually charge more for their flat than non-super users. Okay. So, if we look at the 2 separate regressions, we just type in this in Stata. We regress price on bedrooms if host is superhost equals true. So this is for super users, super hosts. And this is for non-superhosts. Okay, so what we see is that we always check the F statistic first to just see if this regression adds something else than just using the mean of the data, and it does. And we have this regression, which is y hat equals the constant of 326 plus 368 times bedrooms, which is the number of bedrooms. So if there are no bedrooms, which is a studio flat, then the y hat, which is the offered price, is just 326. Okay, but increasing by 368 per bedroom. Okay, and that would be for superhosts, and for non-superhosts you have the estimated price of 200, no, for, let's see, of 452, which is the intercept, plus 285 times the number of bedrooms. So you see that there is a difference between these regressions, and the superhosts, they have a lower intercept but a steeper slope than the non-superhosts. Okay, so let's see, and yeah, so you can use these regressions to look at the difference between the price offered on average by the superhosts and the non-superhosts, accounted or adjusted for the number of bedrooms. And in the next video, we are going to combine these two separate regressions into one regression.